Good morning, everyone. Welcome to the ICP Huawei Challenge. We'll be getting started shortly, so please take your seats. Please welcome to the stage Friedrich Niemla, ICPC Problem Archive Director and ICPC Standards Committee Chair.
Hey, thank you everybody for getting over here quickly. We are ready for the ICPC Challenge powered by Huawei. It's going to be exciting, and it is my pleasure to introduce the Tech Talker. So without any further ado, please welcome Vladimir.
Major mobile operating system, and I will talk this story to you today. One important thing from this slide for you to understand that the number of devices that we are using like every day is increasing, and according to these statistics, it's like in 2025 we should like come to 9 devices per user in average. So it's really a lot of things that surround us every day. Of course, the number one thing is smartphone, but a part of the smartphone there are a lot of other things. And for this like variety of devices, current problem is that each device has either specific operating system on it, or this like operating system is like fully integrated with other devices, and it limits scenarios that we might use in our life with so many devices like working around us. Also, there are some technical trends in smart devices make using the current operating systems not quite efficient. Obvious thing. These like different devices have different like form factors, different screen sizes, even like screens that are dynamically like opened and closed and change its size. For all such things, and especially for the variety of different devices working together, we need like some joint solution. Also, the ways we interact with devices are different. You see, of course, touch interface or some physical buttons or like some physical wheels or even like invisible sensors. You see, I have like a sensor on my hand. It has no screen, it has no button, but it like monitors my parameters like 24 hours a day. So for all kinds of these like interaction modes, we need also a like proper solution. So in Huawei, we decided to solve these challenges at macro level by designing a completely new operating system. The name of this operating system is Harmony OS. If you live outside China, you might not even yet know about it. But in China, it's pretty much popular. It's already like takes majority of the market. And this the principle for this operating system, it's like distributed operating system. This is like principal new architecture solution. So there is one instance of operating system running like in distributed way on all the devices that surround us. You remember 9 devices in average. So there is one instance of operating system, if we are talking about Harmony OS, that can run distributed way on like variety of different devices. And it creates really revolutionary new scenarios for users, because for application developers, they also can take advantage of all this variety of devices. Actually, even for example, you can distribute your application on different devices running at the same time. So like one part of application running on your watches, other part is running on smartphone, other part is running on your car IVI screen, or when you are at home on your TV screen, and it's single application running on all devices at the same time. And actually you can even like tell, okay, I want to move this control, for example, button to, okay, my screen in bathroom. So I want to press specific button or specific application from the screen in my bathroom. It's possible. It becomes possible when you have distributed operating system. So again, to sum up, Harmony OS is the next generation operating system built in like for distributed network architectures, and to be automatically adjustable for like all devices that are surrounding us today. And of course, for application developers, it makes life, because you develop your application not for a single type of device, you develop your application for single operating system, and then everything else by the operating system. So it's new kind of magic in application software development. Okay. Let's like little bit historical background. We released Harmony OS yet in 2019. It was like a limited thing, and at the time it contained a lot of like open source parts, including some Android open source parts. What we did like for the recent years, we gradually added unique like components to the operating system that don't like exist, and at the same time we replaced like some open Android parts by our solution from scratch. And finally now, like the latest version of HarmonyOS does not contain Android parts at all, even like open source parts. So it's even the kernel of this operating system is built using like new principles, like hybrid microkernel with like unique approaches. I know that some of you don't know the operating system, but in reality, the latest statistics show that already now more than 1 billion devices run HarmonyOS around the world. But yes, mostly in China as of now. And one important thing I want to show you at this slide, that HarmonyOS is, the brand HarmonyOS is for devices that are developed by Huawei. So it's a limited number of like 8 types of devices shown in the red area. But the ecosystem of HarmonyOS compatible things are much, much bigger. So we have open source, like the majority of the operating systems that we are developing is in our open source version, which is called Open Harmony at the bottom. And actually, Open Harmony is developed not just by Huawei. There is a like non-profit consortium called Open Atom Foundation. It's a non-profit organization funded by many companies, like I don't remember the number, but dozens of companies are funding Open Atom Foundation to develop this Open Harmony base. Attention to the left part, because now, for example, I was at HDC conference in China. This is the major conference, annual conference conducted by Huawei and partners to show like advancements in consumer devices. And there is a huge hall like this. Oh, good comparison. The huge hall like this, where like dozens of booths of partners who build their own like devices based on Open Harmony. So any like company in the world can build your own like device and your own solution based on Open Harmony. And now there are more than 1,000 such products developed by our partners using our open source like base. What it means for you guys? It means that you can participate in this next generation operating system development right now, because open source is open for everyone in the world. And I personally, I am fan of open source approach because it unites all nations. It's really like for the benefit of humanity. So open source is the way for all of us to collaborate together to make life easier for the whole world. That's what I like the most in this theme. Well, but what I've told to you and these 1 billion devices that we have reached now is just the beginning. Actually, if we ask ourselves, and personally I ask myself like frequently, no answers about, and I want to show you some of these questions. For example, what will be the new OS architecture that will like really achieve optimal resource management for heterogeneous computing? You know, even inside one device there are CPU, GPU, special accelerators, NPU models, and you need, even in one device, you need to like at operating system level schedule it properly. But if we are talking about distributed operating systems, like running at the same time on different devices, the task becomes even more complex. And actually, we have built, in HarmonyOS, we have built like some solution for this. But I am not sure it's like ideal, theoretically, like proven thing. So you might suggest a new architecture that will make this much more better in future. Also similar topic, like what about future operating systems? Should they become like specialized for some areas, or there maybe will be one universal operating systems for all kinds of hardware, like for servers, for desktops, for smartphones? Actually, this is not simple question. Yeah. As I told, all these questions on the screen, nobody have clear answers in the world. So only guesses, and you can participate in answering these questions. And my favorite things is interaction mode with operating systems. You know, now we like press something on the screen or on buttons or tell like something by voice, but still it's like old way. It is assumed that in future we need much more efficient ways for interacting with our like surrounding devices. So devices and operating system in particular should become individually adjusted for each of us. So, and it will talk with you, I mean in general sense, in your personal way, so that, and it will listen to you in your personal way. It will guess your intents before you like explicitly tell them, etc. So your like future smartphone might be a like a perfect friend for you to assist in everything. So he will know about you more than you understand yourself. So the way how we interact with these new operating systems is really open topic. And finally, of course, everyone is talking about artificial intelligence. What will be the role of AI in operating system design, and both inside technically, which components of operating systems will be like run by AI technologies, and from user point of view. Currently, operating system is like a reactive manager of resources, trying to respond to explicit user actions. But using AI, it might become a like proactive, self-organizing entity for you, your partner, that, as I told, understands you better than yourself. And what will be the technical solutions for such like AI-powered operating systems? Nobody knows. Also for application development models, you know, traditional applications that you download from like App Store or Google Play or from Huawei App Gallery, this might be like the end of this era. So these monolithic applications might stop exist in the even near future. So it might be replaced by micro application things, various agents and server-enabled functions that will be coordinated by AI inside operating system. So even for mobile application developers, everything might be changed in future, the way you develop application. And finally, what tools we need to provide for application developers to develop like corresponding scenarios for the next generation operating systems. Because you know, tools are very important. In your like challenges, you will use some tools, but in order to develop like next generation applications for future operating systems, the challenge of which tools are needed for this is also quite open. And I also remind you that developing tools that software engineers use is like a meta level of prestige in software engineering hierarchy. So maybe this is one of the things that you will invent which tools will power application development for future operating systems. Okay, so I tried to give brief introduction to operating systems design and development macro challenges, and now we will proceed to the specific challenge for you for today. And I invite Dr. Zhu from CBG department of Huawei, who will introduce you the specific challenge, and good luck everyone to solve it in the best way.
Good morning, everyone. Visual fatigue and flat user experience. In contrary, on the right, the artistic layout provides unique aesthetic experience. So, the core task of our aim is to take into a set of input photos and tile them into a fixed wise grid, while ensuring this grid is completely covered. For example, this grid has a fixed width of 18 cells. On the right, we can see each photo has several ratio choices. For example, the top left photo occupies 6 by 6 cells. Each size has a unique aesthetic score. The ultimate objective is to maximize the overall aesthetic score. We designed specific rules. Let's start with photo sizing. As shown on the figure, each photo has a list of predefined sizes. For example, 6 by 18, 6 by 12, 9 by 12, etc. Among them, 6 by 6 is a default ratio. This ratio, with its aesthetic score, is always available for every photo. On the right, we see a source image offers 16 different ratios, each with an associated aesthetic score shown in white. This approach offers a controlled yet visually rich palette. Next, we discuss about photo ordering rules. Our photos are enumerated by a top to bottom, left to right order for their top left cells. That is referred to as the key cell. The layout sequence proceeds first to bottom, then left to right, as shown on the top corner of each photo. For example, photo 1 precedes photo 2 because it is to the left. Photo 5 precedes photo 6 because it is positioned higher. Please note, photo coordinates are 1 indexed, not 0 indexed. Please be very careful. They are 1 indexed, not 0 indexed. On the right, we see the photos are logically divided into several groups. These groups must be consecutively placed for their key cells. However, within each group, we allow the flexibility to shuffle the photos for better aesthetic scores. This is where our optimization opportunity lies. Next, we precisely define the input and output format. Our input data first provides the number of groups G and the gallery-wise K. Following this, for every group, we receive the number of photos in this group. For every single photo, we have the number of available ratios and the triplets, width, height, and weight. We see an example below. This example has one group, and the width is 18 cells. It has 3 photos. For each photo, we list the detailed ratio options. For example, photo 1, it has 4 ratio options: 6 by 6, 12 by 12, 6 by 12, and 12 by 6. These 4 ratios are depicted on the rightmost. The output data precisely defines the photo coordinates and the width and height. The width and height are chosen from the input data. For example, this output has 3 photos. Photo 1 is placed at coordinate 1 and 1. Its width and height is 12 and 12. These 3 photos produce a layout as shown on the bottom right. Finally, our scoring function is a sophisticated blend of 4 components. First, we sum up the aesthetic scores for all chosen photos. Naturally, this maximization means we have a better visual appeal. Second, we measure the standard deviation of the 16 ratio choices. If the variance is lower, it indicates a more balanced layout. So we aim to minimize this item. Third, we count the T intersection. As shown on the bottom right, a photo with 12 by 12 cells beside two photos with 6 by 6 cells forms a T intersection. This T intersection is formally defined as a grid point where 3 photos meet, where 2 borders of them are collinear and the third perpendicular. Please note the outer edge is included. Our aim is to maximize this item to enrich visual diversity. Fourth, we apply a row penalty. It is the height of the layout. Typically, a compact layout is preferred, so we aim to minimize this item. The composite of these 4 items are normalized by the number of photo groups. By the photos. Normalized by the number of photos, then it is truncated to be non-zero. So, balancing the 4 items is the central challenge of this problem. That's all about the problem.
Laptop, where am I pointing? Next 4 teams, pad. Next 4 teams, a watch. This is really cool. So please win this thing. There's nothing more to add. You have the problem on your table. You shouldn't touch it yet. You have the login information on the table. You shouldn't count it yet. So could we switch over to the countdown? I think our timing is pretty okay. Can we get the countdown over there? Well, I can see it here. 20 seconds, that's pretty decent. Okay, let's go. Are we ready? We will start in 17 seconds. And 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. Start your engines. Oh wait, that's not it. Thank you all.
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics is really something that once you understand it, you can see the beauty of it. You can see the kind of creativity. For some things it's like art.
Good morning, everybody, and welcome to the 2025 ICPC Challenge held in Baku. We have a problem today, and all the contestants are currently working on it. We'll take a look at them in just a sec here. We're currently 20 minutes into the contest, and we have several teams who have submitted. I'll talk about the rules in this in just a sec. But in first place currently, we have Delft University of Technology with 71 points on this problem. Let's talk about the rules. Oh my goodness, University of Tokyo just made a submit, doubling the best score, putting them into first place with 153 points. 153 point something points is an interesting score. Here's what that means. So this is an optimization problem contest, which means unlike normal contests where the idea is to get as many problems as possible right, with this contest, there are varying degrees of right. So you can get more points for a better solution, but any solution that scores non-zero is a valid solution. Some are just better than others. The idea behind the problem is you have a series of pictures, which you have in your photo gallery, and you want those pictures to be presented to the user in a favorable way that looks good. Each of the different pictures has certain quality scores, I think they call them, or certain aesthetic scores, they say, which is like how good they look in a certain aspect ratio and size, I guess. And you're given for each picture a series of ways of displaying it. You want the average of the aesthetic scores to be as high as possible, but also following other constraints, which are mentioned here in the problem. One of those constraints is there are no empty spaces in the whole grid. So it's kind of like if you look at Photos app, I don't know what other apps are like this because I don't use very many social media myself, but I think that the Apple Photos app, probably Google Photos too, has a certain view where you can see some pictures are bigger, some are smaller, and there's variation. It's not just like a grid, like a 3 by whatever grid. There's variation in the photo sizes. So the goal here is to support that, which makes sense, right? Sometimes you take portrait photos. You might want those to take up more space vertically than horizontally. If everything's a square, it looks a little weird. Apologies for the noise, by the way. There's a talk happening right on the other side of these cameras with maybe 70 people and a speaker with a microphone, so it's a little loud here. But it's a beautiful area, right? So yeah, you have all these photos. Each has a certain aesthetic score, which are floats. Your goal is to maximize the average, and there are certain penalties that you're imposed. So one is the initial total score. You also have a standard deviation of photo sizes that were used, which you want to minimize. That is defined as the number of photos with the jth size from the list, and you want to minimize the sum of those divided by 16, I guess. You want to minimize basically, the standard deviation. And then you have a score which is defined as the number of T-shaped border intersections. And that is good, so you want those. And then you have a penalty, which is the height of the layout. You want to minimize that. So you want to minimize the height, maximize the number of T-shaped intersections, minimize the standard deviation, and maximize the score. There's a linear combination of those that is your final score. And I guess if your score is negative, they set it to 0, which I guess could happen if you use some very, very large-sized photos. So I guess that's the question. You can see we have a big pileup on 68.3 with maybe 5 to 10 different teams having that exact score. What causes that is unclear. It would be wonderful to see their screens. I don't know if that's something that we'll have an option for today, though. We'll have a couple guests joining us. Huawei is one of them. They'll be here in about 20 minutes. Yeah, so it looks like 68 points is a big jump. There's 68 to 73 for Delft, and then University of Tokyo with 153. There's one more part of this problem that I want to mention. That is this idea of collections. So there's a series of collections, and all of the photos within a collection, maybe you go like on one trip or on one vacation or something, the photos within that collection, they all have to be adjacent, where you count the photos from left to right and then top to bottom. Sorry, from top to bottom, and you tie a certain height by left to right. So it's like the natural ordering. So although you have to cover the screen completely, within a single collection, you want all of those photos to be adjacent. Here you go. You can see the teams here in the Baku Convention Center, which is on the other side of the wall that's behind me. You can kind of see it. They're on the other side of that wall. For those of you just joining, this is also functioning as our test stream to test all of the equipment, audio, and everything like that. If you see any major issues, feel free to let us know in the comments so we can get this addressed for the ICPC World Finals happening tomorrow for the real contest, I guess. The National Economics University. There's also a Carnegie Mellon University in Qatar. Interesting. Obviously, there's a well-known Carnegie Mellon University in the east coast of the United States. Pennsylvania, I believe. We have a series of submissions coming in. Looks like several of them are increases here. Now, my understanding of what's displayed, each of these green scores is an incremental improvement from the previous submission by that team. You'll see, for example, De La Salle University, they have an equal sign. What that means is their score on that submission was no better than their best one previously. The score that ends up getting kept for each team is the maximum score. So if you submit, right, that gets 50 points, 150 points, and then 10 points, the 150 is your final score, even if after that you make a worse submission. A couple strategies here that come to mind. Although it seems like you have several collections. If the collections have a certain ordering, within one collection there aren't really that many things that matter. So you can kind of distribute the area per collection, and then once you have that, you can do some sort of DP, where all you care about is the start of your collection, and then the finishing place. I guess the amount of width and height it takes up. I imagine there's other stuff you can do with trying to use the smallest version of pictures as well, or balancing whether the smallest version is better than something else. Perhaps the 68.3 is just some solution to try and get everything on the board in a way that works. Yeah, Universidad del Chile, another solution to problem A, with exactly 68.3 points, putting them tied for 6th with a whole bunch of teams. Only 5 teams scoring better than 68.3. Yeah, let's take a screenshot, or let's take a look at the statement here. Beautiful. We got a red border and everything. Matches the queue. I love it. So in the grid page of the... I hear a phone. We're good. All right. In the grid page of the mobile device OS gallery, an artistic layout is needed to break the conventional design display, offering a unique aesthetic experience and enhancing the surprise and satisfaction of users. This artistic layout must meet several constraints, such as display effects, content integrity, and full coverage. It also needs to adapt to different screen sizes and rotation directions. Yeah, you can imagine this is similar to like the Google Photos app. Is there any way we're able to scroll down on this so people can see the page 2 and 3, I guess? Beautiful, look at that. So we missed a part of the statement, that's fine. No blank spaces are allowed, otherwise you score 0 points. And the width is a multiple of 6. Even more constraints. It's only 18, 24, 30, 48, or 60. But yeah, all of those are a multiple of 6. It looks like we're also given M photos, where each one occupies some rectangular area of A by B, AI by BI. And the top left cell is the key cell. All photos can be enumerated in their key cells in natural order from top to bottom, then from left to right. So if you have 2 cells or two screenshots, the top left is what you care about, and you want the top left one to be above. That would count first. If they're on the same height, the one to the left is the one that comes first. groups, which are groups should be placed in the gallery consequently according to each numeration. Oh, so yeah, so you have a series of groups, but within a group you can choose the ordering. Very nice. Okay. So yeah, so you start with the first group. All that really matters when you're looking at the second group was the amount of height and the beginning of the width of the bottom one that you're using for the first group when you start considering the second group. So you can do some sort of DP there. It looks like all of the possible sizes are selected from this list. So yeah, we have a list of things. It looks like they're all multiples of 3 at the very least, and then some, oh no, I guess there's also 14 by 6, which is very surprising. 14 by 6 is a weird one. Okay, anyway, given the width of the gallery page and a set of grouped photos along with possible sizes and their aesthetic scores, output a layout that has high average aesthetic score. See the scoring section. Okay. Yeah, so in the scoring section, we have a list of what these all look like. The input is the number of groups, the width of the gallery page, up to 5,000. 5,000 is also an interesting number. Is that divisible by 60? Maybe. And K. What is K again? Let me check my printed statement. Oh, the width and number of cells. So then what is the width of the gallery page? That's G.
Hi.
Welcome, welcome.
Hello.
Oh, we're both on camera. There you go.
Yes. Do you want to see the third page of statements?
Yeah, let's take a look. I also, do we have a list of questions for Huawei yet?
It's gonna happen.
It's going to happen. We're going to get it.
I hope so.
Good, good.
Hello. So this is the third page of statements. We might have to
So yeah, here's at the very end. This is the golden formula. Is the final score, which is the average score per photo. And the score per photo is we get a 1/10 value for S, which is the aesthetic score. We lose 10 times the standard deviation. We get 1 point for each T intersection, and then we lose 1 point for the what's H? The height of the layout. Okay. So we want to basically minimize the height and maximize the aesthetic score and the T intersections. Although, I suppose the aesthetic scores tend to be pretty large. Like we're getting some aesthetic scores of like 50. So maybe T intersections aren't too important. It's kind of like small potatoes.
Want to look at the sample again?
Yeah, look at the sample.
Let's look at
Just kind of getting an idea of the aesthetic score. Oh wait, no, but aesthetic scores are divided by 10, right? They are. So maybe 50 is only 5, so maybe T intersections do matter.
So this is the first example. We have input data for that as well.
What is the red path?
I actually don't know. Let's look at the red path again. It is like the case that
Oh, G is the number of groups, it sounds like?
interesting. I'm not quite sure.
Yeah, it sounds like the width of the gallery page, G. So it sounds like we can have up to 5,000 groups of photos, and then each photo has these pieces of info. They also provide a generation script, so we can generate quite a few files if necessary. Sounds like they just have different parameters between them.
Want to see the scoreboard again?
University of Tokyo continuing to improve, and Delft University of Technology also moving up. They had 71 points before, so they're improving here. the huge bottleneck is 68 points. There are two solutions to 68, one 68.8, one 68.3. But that, it looks like that is basically everyone so far. Maybe all of these photos have a certain width, like 4x4 or something, and everyone's just like putting all of the 4x4 ones together. Or 6x6 maybe. I suppose that would work.
We'll be back in a second.
Okay, sounds good. Of course, the winner is the team who is able to end up with the highest score. So having a high score initially is maybe not the most critical thing in the world. What a beautiful picture. What's that? We're going for a run. All right, we will be in a quick commercial break, or maybe at least commentary break after this. We are back with some more commentary here. A couple submissions have happened recently. Notably, the big 68.3s dropped to 12th place. Two I want to mention are, well, three I guess now. University of Central Florida has made 2 submits. One scored them about 80 points, I want to say. And then they get another 20 points on top of that. So I think they're around, what is it, 120 now. Okay, so maybe even more than that. Putting them in 6th place. They were in 5th for the time being. Also, quite a few more top team submissions here. Beijing, Jiaotong University with almost 250 points total, putting them in 2nd place. I believe they were in 5th for a bit. Oh yeah, Kusaga joining the 66.3 club here. He's one of the coaches for North American Championships. When we scroll back up to the top, we'll see some more teams in a bit. I may have just missed it here. Holy cow, 68.3 is everyone. I wonder if that's just 6x6 in order or something. But that's quite a few. Yes. All right, one sec. We will be right back here. Welcome. Okay. You have the question list. Would you guys mind waiting over there for a bit, and then I'll help you just a sec? All right. One of the great parts about this being in the action is that we have so much going on at any point in time. You never get bored here at the ICPC World Finals Baku. Beijing, Jiaotong University, they have improved a little bit to over 250 points, putting them in 1st place. Congratulations to them. We're gonna have Huawei on in just a sec here. I think we have a couple guests. Yeah, do we want to pause for just a sec? All right, welcome back. We have two representatives from Huawei here. We're going to talk a little bit about what it's like to work at Huawei, some of the problem statements you guys have created here, and the day-to-day work you guys do normally. Let's do some quick intros. We have Wu Fan here and Zhu Ran, right? All right, welcome you guys. This is the ICPC Challenge powered by Huawei. So you guys helped come up with this problem, the data sets that were involved, the generators, all that stuff, right?
Yes.
Can you tell us a little bit about like what inspired this question?
I'll take first. So this problem comes from system app, Hot Photos, right? This is a daily app people always using, right? It connects the memories, all the pictures, videos. It is probably the most frequently used app, right, in their daily life, right? So we want to bring the most best user experience, especially it is visually appealing, right? So
Yeah, would you mind moving the mic just a little closer to your... There you go, perfect.
okay. So we so we want to bring the best user experience, especially for the visually appealing, right? So we want someone who can have this question and they can really solving an industrial problem that can bring the user interface more appealing, right?
There you go.
Yeah.
Yeah, it makes a lot of sense because it's like, yeah, you want when you open up the photos page to have a beautiful aesthetic
Layout.
experience. Yeah, good layout. If everything looks the same, it's just 3 squares in a row, row. It gets kind of boring.
Yep.
So yeah, this is a good call for that. I do have one question about the scoring here. I noticed T intersections have a special scoring calculation. The number of intersections that are a T. Is there any reason we chose to do that?
Yeah, let me answer this question. Actually, we want to supply an artistic layout for the gallery, but how to measure the artistic score, it is difficult. So we actually offer several measures. The most important is the aesthetic score. That is the first item. Then we want the layout to be tiled artfully. That is where the T intersection comes from. Suppose a typical layout of the grid is rigid. Actually, there is no T intersections, but we allow we allow several borders to intersect at the border of another photo. That is the T intersection. Usually, this kind of layout generate some surprise and cause visual and aesthetic comfort, enhancing user experience. So we add this item to the scoring function.
Very cool, very cool. I also noticed on the front page we have some red lines drawn through the borders. We were looking at this earlier. Is there any meaning to what these red lines are?
Yes, this is the separation of the groups. Actually, here we see two red border lines. So the overall layout is separated into 3 groups. Each group,
and within a group you can change the ordering, but the order of the groups has to be consistent.
Yeah.
Yeah, the group usually means the daytime, right? The daytime. So people maybe take their pictures from like first day to the 5th day, right? Like this event, right? They want the story, they want their memories in the timeline, right? So yeah, so the group's order has to be specific, right? From the oldest to the newest, right?
Yeah, but you want it to be chronological.
Yeah, during the same day they can be randomly shuffled, right?
Yeah, that makes sense.
But not randomly in this question. Yeah.
You want to do it in such a way where you maximize the aesthetic score.
Yes.
And the number of T intersections.
Yep.
I think the scoring function makes a lot of sense, but I do have one question, especially like if you've tried to like write a program to do this yourself. One question that I have is, you'll see a ton of teams are scoring about 68.3. Do you know what the approach they're using that scores the 68.3? Because it looks like this is an overwhelmingly common score for teams to get. How is that happening?
Yes, I think most probably at the beginning the participants want to have a code to run through the algorithm, but actually the algorithm part is leaving blank. So they just read the input and output the number to follow our format. And actually, this layout is a very simple layout formed by 6x6 cells.
And are all images
Yes.
guaranteed to have a 6x6
Yeah,
cell?
I think this is most probable.
Oh yeah, they
Probably
say in the input
case,
section there's
yes.
explicitly a line saying 6x6 is available for every photo.
Yeah, and the k size can be divided by 6, right? All the k size can be divided by 6. So the easiest solution may be just using the 6x6 aspect ratio to paving all the screens, right?
Yeah, wonderful. And then I also noticed there was something about the standard deviation of sizes. Is that right?
Yeah. Actually, this is the variance of the usage of the 16 different sizes.
Oh, so you're saying you want to use each potential size approximately the same number of times. So you want like roughly an even distribution of like how much you have big photos, small photos, very vertical and horizontal photos.
Yes.
That way it doesn't look monotonous. Wonderful, I see. I want to talk a little bit about like testing these problems. Did you guys write an algorithm yourself to try and solve this problem before submitting it?
Sure. Actually, we have specific test member because he used to attend ICPC before joining Huawei. He proposed several solutions, such like dynamic programming and heuristic algorithm. The solution he proposed in the system actually can rank very high in the rank list now. But finally, he proposed a question that he's quite not sure about how to find the optimal solution. So that is why we think this question is very interesting.
Yeah, it's also quite large, right? I believe there can be up to 5,000 different groups of photos.
Yeah.
And then each of those groups can have several photos, I think up to 10,000, I want to say, right?
Yeah.
So that means, like, within those 10,000, there are many, many, many ways of ordering them.
Yeah.
Like, that's 10,000 factorial. So you can't do anything like that. You have to come up with some way of doing it with heuristics.
Numerous.
Do you know roughly what the strategy that your team member had was?
I'm not quite sure about the details. At first, he proposed a dynamic programming solution. But I think we don't need to go to the
into
details.
depth, yeah.
Right? It is very similar to the snapback problem, but it is a 2D case.
Sorry, similar to which problem?
Snapback problem.
Snapback. Snapback problem.
Snapback?
Yeah.
Okay. And what is Snapback?
I mean, it's kind of algorithm similar like backtracking, right?
Yeah.
Oh, knapsack.
Knapsack.
Okay, yeah.
Oh, we pronounced wrong.
Wrong.
Erroneously.
Yeah. So knapsack is like you want to figure out each thing has a certain weight and value. You want to you're a thief trying to rob something, but you only have so much room in your knapsack.
Yes.
And you want to get the most valuable items that will all fit within a certain weight.
What's
for
more
example.
interesting is in this problem, right? We want all the photos to paved seamlessly, right? We don't want any gaps or blank space appear on the screen, right? That's the key point, right?
The other thing that I thought was a little interesting related to that is one of the sizes you have. I mean, almost all of them, looking at them, they're either 4 or like a multiple of 4, very composite numbers, like 6, 9, 12. They're all multiples of like 3. And then you have 14, which is 2 times 7. You have a 14 by 6 photo. Is that something that's handled separately? 14 by 6 kind of stands out to me. It's like the only one that has 7 as a factor.
Yeah, that is a very spatial ratio, right? Actually, it is. It comes from the a manual design of our designers, because at first this problem is not solved by an algorithm. It is designed manually, and our designers gave such options to some limited patterns to pave this grid completely, and among them 14 by 6 is an option.
And is that just like what a portrait photo looks like on a normal phone, like on a rectangular phone? It tends to be about that?
Yeah.
That makes sense. Wonderful. It looks like we have quite a few more submissions, including St. Petersburg State University, with their first submission getting points, getting 205 points, moving them into 10th place. Congratulations there. National University of Singapore also is scoring quite well with 250 points. They were able to break the 250-point barrier with three more points above their previous submission. And Universidad Federal de Alagoas with another 80-point boost, putting them into 9th place with 225 almost overall. So congratulations to all the teams who are performing there. Let's talk a little bit about your jobs at Huawei, if that's all right. Okay. Would you guys each mind mentioning what you do on a day-to-day basis? Yes, Fan, do you want to go first?
Yeah, actually I'm a software engineer at Consumer Business Group at Huawei, right? So our job is to developing the HarmonyOS operating system. So this is a system that's built upon on an open source project called OpenHarmony, which is also largely contributed by Huawei. Yeah. So this system is actually a platform that powers all kind of devices, including PCs, phones, or tablets. Yeah. So the main task for us is to build the system apps or the system SDKs, either to the customers and developers respectively, right? So actually my job is mostly the daily job is to just developing, right? Just to bring the all the new features, all the new APIs into HarmonyOS. And we have a small team, building on the multimedia domain. And the Photos app is actually belongs to the multimedia domain, right?
So that's something you guys have worked on.
Yeah.
Wonderful. That's very cool to see that problems like this, these optimization problems, are something that you see on a day-to-day work.
Yeah, we actually want to bring an opportunity for the students coming to solving the real industrial problem, right? Even though they are not exactly the same, because we do have a lot of restrictions on the edge devices, because like phones, we don't have that kind of computing power.
Yeah, also for these questions, if I understand correctly, you probably, it doesn't have a specific time limit here, but I imagine you have a couple seconds allowed to run your program. For a phone, if it has to show this to render the app, you can't freeze the phone for 2 seconds to determine how to render the page.
Not even 1 second.
You have like a couple milliseconds, maybe like 10, 20 milliseconds, right? Yeah. So it's a very different type of algorithm that you have to go. And I imagine probably you aren't concerned with quite this many photos either, right? You probably don't have 10,000 photos in a single day.
98% of the population, they may have like less than 20,000 photos, maybe. Yeah. But some of them can have like more than 500,000 photos on devices. That's really
and the app still has to work.
Yeah.
The app can't crash. Yeah. Wonderful. Juran, what do you do on a day-to-day basis? Are you also a software engineer?
I was, but now actually Wufan provides the source dataset, and we generate random data generator from the distribution of the data. As you know, we depicted in the last page, we offer the random generator to the to the participants. So the data distribution is open for them. We supplied two kinds of distributions: the Gaussian distribution and beta distribution, and several kind of parameters to simulate the real distribution of the real consumer scenarios.
So you try and model the types of things that real people have on their phones, so that you can come up with these training sets to evaluate the quality of algorithms that people come up with for problems like this.
Yes.
And then are there, other than, for example, the Photos app, are there different types of distributions you try and model as well?
I think so. Actually, there are some specific distributions besides Gaussian and beta, but I think a general solution should work well for all of these distributions.
And what is the main difference between, for example, a Gaussian distribution and a beta distribution? Would you mind explaining for us?
Yeah. For example, if the data set is set to, if the data is set to Gaussian distribution, that means the aesthetic score is centered as a certain value, but with a variance of the with a variance around the mean value.
So would that be like a normal distribution? Is that the same thing as a Gaussian distribution?
Yeah.
So roughly, like if you look at heights among males,
yeah,
those have roughly, there's a some mean height, and then after that it kind of curves off. You have a bell curve.
Yeah.
Okay. And then what does a beta distribution look like?
Actually, beta distribution can form different kinds of shapes, both the mountains and the
valleys.
Valleys. Yeah. And even flat distribution.
Like uniform, uniform distribution. Yeah.
And it can control the mean value. It can move the mean value to the left or to the right.
And what would be an example of something in the real world that might have a beta distribution?
Yeah, in real application scenarios, suppose you are an expertise photographer, the mean value of the aesthetic score might occupy the higher part of the aesthetic score distribution. But for typical consumers, I think the mean value might be lower and the variance is higher.
So you have kind of almost two normal distributions combined.
Yeah.
One for the professionals who are very good at taking these photos, they have a lot of aesthetics, and one for everyone else who's it's more general, but it's lower on average.
Maybe more cases than these two. But I
more complicated
they
things,
are typical.
Gotcha. I see. Yeah. So like a bimodal distribution, for example, that would be usually a beta distribution. If it has like two common peaks.
Yeah. This is a special case. Actually, some we know the x-axis is the photo number, right? So sometimes the photos get very very low aesthetic scores, but if you crop them in another style, they will appear visually comfortable.
Mm-hmm.
For example, our photos can be taken vertically or horizontally. So these two ratios typically get high scores. But if you crop them to other sizes, they might get lower scores.
Or if you crop a vertical photo, like a portrait photo horizontally, you'll have a low score as well. That makes sense. Fan, is there any time in your day-to-day operations as a software engineer that you've used distributions like this to check the quality of algorithms?
Mostly normal distribution, right?
Okay.
So, like Juyuan said, the aesthetic score distributed like like Gaussian distribution, right? Usually, most people make it a score like 70-ish, maybe. Yeah. The range is 0 to 100. Yeah.
I see.
So the score are coming from some AI algorithm, AI models, right? Which was trained by other department. Yeah.
Yeah.
So yeah, we just use directly, we just directly use that score. Yeah. But sometimes the score needs to be refined a little bit. Yeah, because it only represents the training data set, right? That cannot represent the whole world, the whole population. Yeah. So that's the main problem, I believe. Yeah.
There's another very interesting question, of course, which is like, how do you calculate those scores for a given cropping of a photo? And maybe that's a question for another time. But obviously, like, yeah, you have some neural net somewhere does something, but the calculation for that and like how you generate the training data for it it's an interesting question.
Yeah. So we usually connect all the photos, right? Either by buying them or by collecting from our engineers themselves, right? They go to different places taking photos, and we.
How do you get the labels for them, though? How do you know which ones are good, which ones aren't?
That's a very good question, right? So the label score usually was labeled by some photographers. I mean.
Oh, manually, like
manually.
Some experts manually look through them and it's like, this is really good, this isn't.
Because the aesthetic score is really something that cannot be calculated using the math, right? It is by the people, right?
Yeah, yeah.
Yeah, and we measure this algorithm by using the correlation relationship, right? We give a set of photos, right? Anyone can give them a score, and we check whether the human label and the machine output are linearly correlated. That's the one we measure how good the algorithm is. Right?
Yeah, interesting. Very cool. I imagine there are other use cases, like probably, I'm thinking like for YouTube videos, for like the thumbnails, there's other source of truth information you could use. Like probably I imagine if the thumbnail is more attractive in some way, people are more likely to click to watch that video than some other video.
That's right.
So maybe there are other sources of labels you could get for that. But yeah, I guess sometimes it depends, and then you get into the question of like where are you getting the data, and it's maybe a mess. But yeah, thank you guys. This is a wonderful question. I'm interested in like what all of the different teams are thinking. It looks like we have a new team in first, whose name just disappeared, so I kind of lost that. I think this is a coach, Nikita Golikov. I don't remember exactly what university he coaches, but he's now in second. We have both teams and coaches competing here. Another coach in 4th place and another one in 54th with some minor optimizations here. You can see it looks like teams have gone through most of their huge low-hanging fruit, and now they're finding where they can get another 5 or 10 points. The 68.3 squad is growing quite a bit. IIT Kanpur with another 1 point, giving them a total of 146 here. Are there any universities that you guys are rooting for?
Yeah, I noticed Beijing Jiao Tong University from our country ranked first at the time, but now where is it? Seems still the top 5, right?
Let's take a look at the scoreboard here. Looks like, yeah, they're 5th place.
Ah, the 5th place, yeah.
We had my home university, University of Central Florida. Don't worry about that, by the way. They're working on some other stuff to try and let us switch the cameras automatically, but that's not affecting the stream. My home university, University of Central Florida, they were in 6th place a while ago. It looks like there's been some general growth in people's scores, though, so people are performing quite well here. All right, wonderful. One other question for you guys. if people are interested in working for Huawei, where would they get started with that? What would you recommend to those people who might be watching the stream today?
My recommendation is that to learn some basic science, right? My major is physics, actually, not computer science, but to build a solid foundation for the mathematics, physics, those kind of courses, that really helps a lot.
Wonderful. Juran, any advice?
I think there are many such algorithmic problems in our company, but the most important before solving them is how to abstract the industry problems to a mathematical problem or an algorithm problem. Such an abstraction capability is required in our work. Anyway, we have many PhDs to do the abstraction work, and they will give much help for the interns and the new people.
Wonderful. All right. Well, thank you guys so much for joining.
Thank you.
If you have any last thoughts about the problem set, we can share them now with the stream. I guess. Do you guys anything else you want to mention about the problems today?
I think that's
Any
a
last thoughts?
wonderful problem.
It is a wonderful problem. Yeah, it's very nice. The pictures you guys chose here are also quite pretty. Lots of blues, lots of nice landscape scenery. So I want to compliment you on those choices. Thank you guys for joining the stream today. And best of luck at work.
Yeah, thank you.
Thank you.
All right. See you guys around.
See you.
We are back with the freeze coming up as of... How about now? I think we have a volume switch here. How's that? That better? All right. We're still learning all this new tech stuff. We have just encountered the freeze for the ICPC challenge. The freeze happens at 2 hours when we have 1 hour left on scoreboard. The interesting part about the freeze is that although teams can continue submitting and they'll see the results of their own submissions, they won't see the results of other teams. You can see UCF, for example, they've just submitted. They're in 50th place currently, but it's possible that this additional submission has given them marginal increase in points, which would move them up on the scoreboard. They would know how many more points they've gotten based on their submission, but another team like University of Tokyo, who's currently in second, they don't know whether or not they've been passed. We'll have, just like a normal contest, a resolver happen after the fact to have a grand reveal all sped up all at once, and probably award prizes. Historically, we've had some very interesting ones for the top three. I'm not sure exactly what's happening this year. It may have been announced earlier, but we were sorting out technical stuff during the initial announcements. Yeah, we've seen a gradual increase. It'd be really cool to see a graph of the top scoring team over time and just see that go up. I don't know if we'll be able to make that after the fact. I guess we do have the historical data for it. But that'd be very interesting to see, like, how much does the best team get with more time? Like, how much does time help here? And I wonder if it probably plateaus. That would be my guess. But it would be interesting to see if it really does. We're seeing submissions flood in, despite there being an hour left. One strategy you can use if you do have a very big change that you think might, like, set the stage, and if you're in the top place, is hold off on submitting it until after the freeze. This is something that my team has actually done in more traditional algorithmic contests. There was one instance where there was a series of problems. We had all solved the 7 of 10 easiest ones, and there were 3 remaining ones. So we had to choose roughly like an hour and a half to go, which one to go after. With like 63 minutes left, we had finished coding it, and we didn't want to reveal to other teams which one we had coded, which one we thought was the easiest. So what we chose to do was wait 3 minutes before submitting, and then submit also to the other 2 problems. So we submitted 3 problems. 2 of those were just empty files. But the third one, it was a real file, it was a real submit. Ended up being wrong, but we got it later on in the contest. So it was a fun little hidden ball trick, I guess, for various teams. Mike, the founder of Code Forces, is just behind the camera here. He's running a push-up challenge that'll be happening later today. Mike, if you do want to join the live stream, you're very welcome to. You don't have to, but we would love to have you. I think we will have him on in just a sec here. Hi, Mike. Welcome. Would you mind putting these on here?
Just my quick appearance. I just want to promote my push-up challenge today. So, will you join it?
Of course, of course. I'm very excited. So, just so people know, this is sets of 25. Right, and we're doing as many sets as you can do.
You know, we call it rounds.
Rounds, yeah.
Code Force push-up rounds.
Yeah. You do as many as you can, and then people drop out over time.
Yes.
And I heard there's some prize that might be,
we
awarded.
Have small gifts and main gift.
Well, I'm excited, and we're streaming it to your Instagram page, right?
Yes.
All right. Yes. So everyone, if you're watching from home, go check out Mike's Instagram page. Yes. It's also, we'll probably have it on, will it be on Code Forces? Will it be on Code Forces? We have a link to your page on Code Forces, right?
Oh, probably yes.
Okay.
Yes.
In the comments at least.
Okay.
Wonderful.
Okay.
Well, thank you so much. It was great to see you.
See you.
I'll see you later today.
Thanks for inviting.
All right. And there was Mike, founder of Code Forces. He's great. We're continuing to see a flood of submissions here. we obviously don't know anything about these submissions. We don't know anything more about the problems. So it's a very limited period of information this next 55 minutes. Moscow Institute of Physics and Technology, MIPT. They were a fan favorite several years ago. Looks like they're struggling to pass the 68-point hump. There were a ton of teams who reached that but weren't able to do better. Apparently that's the 6x6 solution that gets you there. Dynamic programming is, of course, one of those approaches. It does something. It lets you consider, I think, the different dates. In a vacuum. University of Central Florida with another submission on A. They had a strong start, and then it seems like have fallen behind a little bit. You'll also notice some of these are university names, some are coach names. We have a mirror for the coaches where they're able to participate as well. Usually for these, we have a coach scoreboard and a contestant scoreboard that are separate. I'm getting a thumbs up. I think that's also the case this year. Here's the joined one. University of Tokyo first place among the teams. And a coach first among the coaches here. Andrew, ASC, or I guess Andrew Stankovic himself, ASC or his contests, Andrew Stankovic contests. He's authored, I think, over 40 contests on Codeforces. These aren't the traditional Codeforces rounds. These are like training rounds. But they cover a lot of topics that he's interested in. And they help train a lot of teams. Even my teams, like he's never been a direct trainer for teams at UCF as far as I know. But many UCF teams and certainly other teams have done virtual participation rounds of his contests on Codeforces. There's a lot of cool stuff that he's taught, especially with like certain automata. I forget what they're called. There are two types of them. It's something you learn in discrete. I'm forgetting though. It's where you have a letter and you move to another node in a graph, and you can compress different types of string automation, I think is the name. Beijing Jiangtao University. I think that was home of some of the speakers from Huawei. All right. We'll be back in like 40 minutes or so to announce the conclusion of the contest, and a little bit after that for the resolver. But we'll continue to stream the scoreboard here and the submissions that happen. Unfortunately, you won't be able to see the results for a bit, but it should be a fun challenge. Yeah, check back in an hour or so for the final announcement, and then check back tomorrow for the real contest. Thank you all very much. We are back with Andrew He Eknerwala here. He'll be a commentator with us tomorrow with some other guests. And hopefully we'll have some visualizations of solutions that they're going to set up in the back for us. Andrew, have you seen this problem at all yet?
I haven't really looked at the problem. Can you tell me a little bit about it?
We've got a statement for you. If you don't have to read it if you don't want to, but I'll tell you a little bit about it. You may be familiar with the Google Photos app. Huawei has their own operating system, and they have their own Photos app. And it shows something kind of like what's on this screen, where they have different photos taking up different aspect ratios on the screen. And the app gets to choose what aspect ratio to use for each photo, where it prefers some different aspect ratios because they look better for the particular picture. Maybe portrait ones you want to show in a more vertical vertical shot,
right?
And then landscape ones more horizontal. And there are a couple of requirements. The first requirement is there are no blank spaces on the app that aren't covered by photos. And then the other requirement is you have timestamps for each of these photos, and they're grouped by day. So the red line here, those are separations between different days. So there are 3 different days on this picture.
Here, we can show this the diagram on stream.
Oh, wonderful.
Yeah.
Exactly, yeah. So here you can see those first 4 pictures. Those are from the first day collection.
Right.
Of those 4, you can put them however you'd like. You can change that order however you'd like. But those 4, you have to have those, and those are in row major order, I guess.
Right.
Those 4, they have to all come before anything in day 2.
Right.
And then day 2, you can order them however you'd like. The reward function that you're trying to optimize for looks at a couple things. You want to maximize the aesthetic score on average of all of the photos you show. And you want to use roughly an equal number of each of the photo sizes. So you have a bunch of different sizes. You have like 10 or whatever different sizes, 16 different sizes. You want to use roughly the same, like roughly each size the same amount of times.
Right.
That's a standard deviation penalty. You want to use more T-shaped borders. So you can see the 12 by 12 right above it.
Right.
There's like a T.
Right.
So you get 1 point for each of those, and then you lose a point for each height that you use. So you want the total, like you don't want them to have to scroll too much, I guess.
Right.
And yeah, apparently the thing that contributes most here is the aesthetic score. That's like the most important one. The other ones are kind of
Yeah.
technical.
And is that about like how far off the aspect ratio is from the photo's desired aspect ratio?
Well, it's actually completely arbitrary. They just give you a bunch of sizes that are valid for each photo, and then the score. So they could give you whatever they want. I imagine in real life it would probably be close to that.
Yeah. And it could be computed with like, for instance, maybe they do some like human detection, like image recognition, to actually find the size of the humans in the image.
Yeah, apparently in real life there's an ML model.
Right.
Throw it into some
and that's how you actually determine. So it can vary a lot depending on the photo. Right.
Yeah.
And then so that's it's pretty interesting. So it's pretty like it seems pretty going into it, it seems like there's a lot of room for optimization, and also like it would be really nice to like kind of get a sense of what the representative data is, right?
Yeah, I guess one thing to keep in mind is there's a lot of data here. There are 5,000 days, and then within each day there could be up to 10,000 photos per day.
I see.
So yeah, and then obviously there are that many factorial ways of ordering them, and then each one has like 6 different choices for. There are 16 different choices for the aspect ratio, so you have a massive search space.
Right. So I guess, the only thoughts I would have are, we should try and play with some layouts, and probably like there's some like general techniques like simulated annealing that would do quite well here, where you kind of iteratively optimize your layouts and see how that goes.
So one thing that I do want to mention, we had a huge flood of people score 68.3. That is likely what happens, talking to the Huawei folks who built the problem, that's likely what happens if you use only 6x6 photos. And there's a guarantee in the problem that there's a 6x6 available for every photo. And I guess also there's a guarantee that there are at most 10 to the 4th photos in total.
Right.
So you can just put the photos in chronological order, use 6x6 for everything, and that scores you about 68.3. So obviously a lot of room for improvement on top of that.
Right.
But yeah, because like that one, you'll have terrible distribution because everything is the same type.
Right.
So it won't be very artistic. You'll have no T intersections. And your S score is just whatever you make of it.
Right. And so right now we have the scoreboard, and this is a provisional scoreboard, right?
Yeah.
And this is the scoreboard as of 2 hours into the contest. So there have already been like 50 minutes of extra solving that is not reflected in the scoreboard. But the scoreboard here, we can see at the top. There's a variety of people. You'll notice that there are some names on the scoreboard. These are actually the coaches. These are some of the coaches who are present here, and they are they're given the opportunity to solve the same challenges as the contestants. I think one notable difference is that the coaches actually are allowed to use the internet, and the contestants are not. So maybe the coaches are using some other tooling or looking some things up, or even using some AI assistance in order to get these solutions.
I would love to see how different AI agents are able to compete on this task. Like if you give it all the MCP tools it needs, is it able to do it well?
Yeah.
I don't know.
And we have a few solutions. We have a few visualizations of solutions. I mean, this is what David was saying earlier. The easiest solution is just all photos are 6x6.
It's a beautiful thing, by the way.
Yeah. So this is I don't know. Is this visualizer provided to the contestants? I think it is not. It doesn't look like it is.
Yeah, I didn't see anything about it in the statement.
But that is a thing that contestants should consider building themselves.
Yeah.
When you start with these things, often you want to look at the results that your programs are outputting, and just looking at them can give you a lot of insights into how to what kinds of cases you might be failing and what kinds of ways you should optimize. Especially and if there are any just like bugs, you can more easily see them.
Yeah, if you're going to be working on this for 3 hours, spending 30 minutes or 45 minutes coming up with a way to debug it, makes sense.
Yeah.
Can we take a look at any of the better approaches?
I'm looking. I think production might be sending some more.
We've got another one coming? All right. Sounds good.
Yeah. And I think all of these solutions that we're looking at are going to be pre-free solutions, just so that we don't spoil the result of the of the challenge. I think the challenge awards. When are they going to be? They're going to be later tonight, right?
Later tonight, I've been told. Yeah.
Yeah.
I also another thing worth mentioning here is that because each of the days needs to be in the same order that's fixed, the only thing you really care about when starting day 4, for example, is where day 3 finished,
right?
And then how far over. What the bottom part looked like. Everything else,
right?
You can do whatever order you feel like.
Right.
So you can do some sort of DP stuff with that.
Right. Each day is pretty independent because you're not allowed to reorder days, right?
Yeah.
But the frontier between days can have some funky shapes.
Exactly.
Yeah. That is pretty interesting, and I wonder if any teams are going to have any kind of like DP, kind of a checkpoint between various days.
The only other thing we noticed is if you look at the bounds for the pictures, it's at the bottom of the system model section. All of them seem to be like multiples of 3,
right?
Except for the number 14 by 6, which is kind of wacky.
Interesting.
So I wonder if like special casing that or coming up with some way of handling that is worthwhile.
Right, because 14 by 6 doesn't tile so nicely into the width of the photo, right? If 14 by 6, I guess you can do like a 14 by 6 and a 4 by something. 14 by 6 and a 4 by 6 together add up to an 18 by 6. Right?
Yeah, that makes sense. I guess.
So maybe that's the kind of that's when you want to use this 14 by 6. But it's a very weird number.
I guess is 28 divisible by 3? No.
No, right?
So
you need 42.
Yeah.
But yeah, I guess the idea is that most numbers here are multiples of 3 except 4 and 14. So maybe we like try to pair those up to keep our numbers good.
I think that makes sense.
Yeah.
One of the things we'll also be showing in a bit more detail tomorrow, hopefully, is behind me we have live art being made. There you go. I'm out of the way, kind of. So we'll have a quick break tomorrow where we can see that. Do we have a second example coming up soon?
Okay, I have some higher scoring solutions. So this one is a 275 point solution. Let me see if I can. I guess you can just see the middle fragment of it. Oh.
Let me duck out of the way here. Are we doing manual focus? There you go. You can see the beautiful, beautiful art there. And that's us. That's Andrew and I.
Yeah, so here you can see this is a 275 point solution, and one thing that's interesting about this solution is it proceeds entirely in rows of, I guess they're all height 6. Further down in the solution, you can't, it's a little cut off in the stream. There are rows of height 12, but here in this solution, every single row, there's like vertical T-shaped intersections, but there's no things that span multiple rows. So looking at the example, there's nothing that looks like three stacked together on the left and the one on the right. We only have full rows.
I guess one of the things that I'll note there is that you're getting a ton of points from T-shaped intersections. Like basically everything has, 4, but they're shared, so I guess 2
right
T-shaped intersections that it's corresponding to.
And this also makes your state easier, right? Because you don't have any funny boundary frontier shapes or anything.
It's always just a line, a vertical line, and then another line. So it's basically just the width that you care about.
Yeah, it's pretty much just the width. Here's another 275 point solution. I think this is probably from a different team. But here we see that there are like plenty of things that are spanning multiple rows, and they're arranged honestly pretty haphazardly. It looks. I don't really see any like great. I don't see any basic heuristics for how this is arranged.
Yeah, I mean, like, I kind of see a square in the top left, and then a similar sized square below it.
Yeah.
But yeah, it's interesting. Like, I don't know where this would come from.
Yeah, this is packed very, very densely, and also
do you know how many is 275 points you said? So quite a good score.
Yeah. So it looks like there are a lot of different approaches that can reach, pretty similar scores and pretty, with just a lot of different approaches.
It looks like this one maybe gets fewer T points, but a higher score in the standard deviation penalty, because it's using a bigger variety, it seems.
Yeah. Another thing, here's a quick preview at the first non-zero submission. I think this scores 68 points. And
we do have 15 seconds left in the contest here, so we might have a countdown. But sorry, go ahead.
Yeah, and as you can see, it pretty much is just printing out 6x6 every time, and it just increments the size.
Doesn't even read input.
Barely
it does read input. Yeah. And that's the contest.
Yeah. we'll have to wait until later this evening when we'll be able to reveal the results. I think we'll be live streaming that as well, the award ceremony, and between then there will also be a coaches award ceremony to just celebrate all the coaches that are here with all the teams.
And don't forget, tomorrow we'll have the official real contest that everyone's waiting for. So tune in then. I think we're scheduled for an 11 a.m. start Baku time, but it might be a little bit earlier depending on if we warp the clock.
Yeah.
As usual. All right. Thank you all for watching. We'll be back with the Resolver in an hour or two. A couple hours.
Few hours.
We'll see.
Yeah. All right. See you guys all tomorrow.
数学是最赤裸裸的东西，它直接告诉你一个事情的一个现象的本质，背后的本质是什么。
And mathematics